Hello everyone, I am from Institute of Aeronautical Engineering, Hyderabad, Department of Information Technology. I would like to give a seminar regarding to Tech Talk, and my subject is chemistry. Subject code is AHSC06, and my selected topic is rechargeable batteries and battery management system design. I am Govardhan. Rechargeable battery. First, what is rechargeable battery? A rechargeable battery, storage battery, or secondary cell is a type of electrical battery which can be charged, discharged into a load and recharged many times. It means we can use many times, and it is composed of two or more electrochemical cells, mixture of cells, combination of cells. The term accumulator it used as it accumulates and stores energy through a reversible electrochemical reaction. Rechargeable batteries are produced in many different shapes and sizes based on their condition and usage of the material. Several different combinations of electrode materials and electrolytes are used, including lead acid, zinc air, nickel cadmium, nickel metal hydride, lithium ion, lithium iron phosphate, and lithium ion polymer. Here we see the cells of some company, that is rechargeable batteries. We can use it again by recharge. Rechargeable batteries typically initially cost more than disposable batteries but have a much lower total cost of ownership and environment impact. It means it have some more cost compared to one time use batteries, because we are using this battery many times, so it have some cost. Billions of dollars in research are being invested around the world for improving batteries, and industry also focus on building better batteries. Many of the scientists are investing improving battery management system and batteries life. Charging and discharging. During charging, the positive active material is oxidized, producing electrons, and the negative material is reduced, consuming electrons. By this process we can get charge. The energy used to charge rechargeable battery usually comes from a battery charger using AC, means electricity all throughout. Some are equipped to use a vehicle 12 volts DC power outlet. The voltage of the source must be higher than that of the battery to force current to flow into it, but not too much higher or the battery may be damaged. Charging a battery incorrectly can damage a battery. In extreme cases, battery can overheat, catch fire, or explosively vent their content. Diagram of battery discharging process. Here is the some parts of the battery. Copper current collector, lithium conducting organic electrolyte, aluminum current conductor in plus sign, LiXC6 in minus sign, LiXCO2 in plus sign. Can you see this picture? It is the battery discharging process. Electrons flow from negative sign to positive sign. Applications of rechargeable batteries. Devices which use rechargeable batteries include automobile starters, portable consumer devices, light vehicles, motorized wheelchairs, golf carts, electric bikes, bicycles, and electric forklifts. Road vehicles like cars, vans, trucks, motorbikes are using batteries. Trains, small airplanes, tools, uninter power supplies, and battery storage stations. Emerging applications in hybrid internal combustion batteries and electrical vehicles drive the technology to reduce cost, weight, and size and increase lifespan and cycle stability. Some real-time example: car batteries we are using in motor vehicles. All motor vehicles we are using rechargeable batteries. We can use it again by recharging. And a motorized wheelchair, all people who are not supposed to walk, they use this wheelchair by using battery. If batteries are used repeatedly, even without mistreatment, they lose capability as the number of charge cycles increase until they are eventually considered to have reached the end of their useful life. If the same battery we are using many times by did not servicing and we did not treat it as well, it loses its ability to charge and give energy, and their lifespan will be ended. Its lifespan will be ended. Battery management system design. A battery management system, it also called as BMS, is any electronic system that manages a rechargeable battery, cell or battery pack, such as by protecting the battery from operating outside its safe operating area, monitoring its state, calculating secondary data, reporting the data, controlling its environment like temperature, pressure, authenticating it and or balancing it. A battery pack built together with a battery management system with an external combination data bus is a smart battery pack. A smart battery pack must be charged by a smart battery charger. Monitor. A BMS means battery management system, may monitor the state of the battery as represented by various items such as voltage, total voltage, voltages of a individual cells or voltage of periodic taps, temperature. In temperature, average temperature, coolant intake temperature, that means how much time taken to cool the battery, and coolant output temperature, what is the temperature increasing in output, or temperatures of individual cells. Coolant flow for air or fluid cooled batteries. Current in or out of the battery. It monitors. Electric wheel system, energy recovery. The electric vehicle system's energy recovery. The BMS battery management system will also control the recharging of the battery by redirecting the recovered energy that from regenerating braking back into the battery pack, typically composed of a number of battery modules, each composed of a number of cells. Battery thermal management systems can be either passive or reactive, and the cooling medium can either be air, liquid, or some forms of phase changes. Air cooling is advantageous in its simplicity. Such systems can be passive, relying only on the convection of the surrounding air, or active, utilizing fans for airflow. Commercially, the Honda Insight and Toyota Press both utilize active air cooling of their battery systems. The major disadvantage of air cooling is its inefficiency. Large amounts of power must be used to operate the cooling mechanism, far more than active liquid cooling. The additional components of the cooling mechanism also add weight to the BMS battery management system, reducing the efficiency of batteries used for transportation. Here is the uses. Here wireless BMS used in car, and is the system inside system of the BMS cooling system. You see that two pictures in the slide. Battery management system, main controller of the, can you see this diagram? Main controller, power interface, cell data, controller power, controller signals, external circuit power, load, charger, current sensor, current limiter, pre-charge contactor, ext monitor output, ext ISO digital analogous IO, ext ISO net cans. Here these are the parts, and it diagrams tells about how the BMS main control work. So now you understand how this work. Now we go to another slide. Protection, how to protect it, BMS. A BMS battery management system may protect its battery by preventing it from operating outside its safe operating area, such as overcurrent may be different in charging and discharging modes based on situation. Over voltage during charging, especially important for lead acid and lead ion cells. Over voltage will be come. Under voltage means less voltage during discharging. During discharging, less voltage will also come. Over temperature means increase in temperature, more temperature is present. Under temperature means low temperature. Over pressure means more pressure exit in the cells, NIMH batteries. Ground fault or leakage current detection system monitoring that the high voltage battery is electrically disconnected from any conductive object touchable to use like vehicle body. Balancing. In order to maximize the battery capacity and to prevent localized undercharging or overcharging, the BMS may actively ensure that all the cells that compose the battery are kept at the same voltage or state of charge through balancing. The BMS can balance the cells by wasting energy from the most charged cells by connecting them to a load, such as through passive regulators, shuffling energy from the most charged cells to the least charged cells balancers, reducing the charging current to a sufficient low level that will not damage fully charged cells, while less charged cells may continue to charge. Does not apply to lithium chemistry cells. Distributed battery management system working principle you see in this diagram. Main controller, power interfaces, and BMS power, cell data, control power, control signals, cell data, some external, parts are there. So now you understand load, charge. That is the principle of working. Finally, I hope you all understood about battery management system and rechargeable batteries. So thank you all for watching my video.